Hello everybody and welcome back to my YouTube channel. I am Varshini from Sri Venkateswara College of Engineering, and today we will be discussing on the subject Object-Oriented Programming with Java, and our topic for today is an overview on Object-Oriented Programming or OOPS and Java and its implementations. So let us look into an introduction. Object-oriented programming is a programming paradigm based on the concept of objects which can contain data and code to manipulate that data. And OOPS allows the designing of software and modeling of real-world entities as a subject, promoting code reuse and modularity. So what is OOPS? OOPS basically stands for Object-Oriented Programming, and this is an approach towards programming. The conventional approaches were POP, that is procedural programming, but now we use the concept of OOPS. It uses the main theme of objects, which is a real world entity, or it is also called as an instance of class. This object is used to relate to any real world object, that could be a pen, a notebook, a car, a fruit, or anything as such, and then try to manipulate that into a program. That is the overall concept of OOPS. Let us look into a few principles of OOPS, at least the ones that are very important to us. It will be the four major principles of OOPS are encapsulation, abstraction, inheritance, and polymorphism. We have other ones also. It could be class, object, or attribute, and methods, and other such things. But the four main ones are here. They help in organizing and managing complex software systems by defining clear relationships and interactions between objects. How are Java and OOPS related? Java is a widely used programming language that supports the principle of OOPS. Even other languages like C and C++ also support the programming concepts of OOPS, but in our case, we'll be looking into the Java point of view. Java's syntax and features are designed to support the creation and manipulation of objects, making it a powerful tool for building modular and scalable applications. Classes and objects. Definition. A class is a blueprint for creating objects or instances defining their properties and behaviors. Objects are instances of a class. They interact with each other to perform tasks and represent real-world entities. In Java, classes and objects are basic concepts of OOPS that are used to represent real-world concepts as entities. The class represents a group of objects having similar behavior. Let us look into an example. An animal type dog is a class, while the particular dog named Tommy is an object of the class. Let us consider the example considered here, that are dogs. Let's say we have a dog in our neighborhood. One is Tommy, and let's just call the other one Bark. And then when we look back at Bark and Tommy, both of them are dogs, but one of them is a retriever and the other one is a Labrador. When we look into these changes, they all have their own characteristics. That is, Tommy may weigh more than Bark or anything like this. So when we look into topics like this on a bird eye view, they are all still dogs. Even though you consider 20 or 30 of them, they're all dogs. They might be different in terms of characteristics and properties. So, and their names, their weight, it could be so many things that differ in them, but then they are still coming under one single category, that are dogs. The concept of class works in a similar way. For our example, the name or the idea of dogs is like a class, and then Timmy, Bark, and any other dog that we are considering would be considered as an object. We have a picture here where the identity is the name of the dog. How we recognize Tommy is because he's Tommy and we call him by his name. And the attribute for Tommy is his breed, his age, and his color. That could be a white retriever, a black retriever, or anything like that. And its behaviors are barking, they bark, dogs bark, and they sleep, they eat, they drink water, they go on walks, they have fun, they do all these things, they are excited to play with their owners, and all these things, they come under the behaviors of a class or for example, in this example, it's a dog. We have four major paradigms or four pillars of OOPS that we consider. OOPS has many of these characteristics that make it more effective compared to the other counterparts available, the POP or anything else. The main ones are encapsulation, abstraction, polymorphism, and inheritance. What are these things in general? We'll look into them one by one, but in general, encapsulation means the collection of variables and methods. They are all binded together inside one class. Variables and different variables and methods are binded together under one class. This concept is called Encapsulation. And when we come to abstraction, abstraction is a way of hiding unnecessary information from the user. In the front end, we may not require the user to know everything that is happening on the coding part. So we'll have to hide or just morph some of these details that are unnecessary. This hiding of information is called abstraction. This helps us in privacy and other security purposes. Inheritance is a very simple and easy concept. That is, it is a process where one class inherits the properties of another class. Let's say we are trying to add two variables and two strings. In both of the cases, the major task that is being performed by our code is just adding both these things, though they differ in data types and other things. So you can create one class called add, which will be a superclass, and these adding of strings will be a subclass, and adding of number will be the second subclass. This is the concept of inheritance. Next, we have polymorphism. Polymorphism is just basically sending one message in to different places in different form, or to be able to pass a message in more than one form is called polymorphism. Now let us look. Inheritance is a mechanism where a new class or a child class inherits the properties and behaviors from an existing class or a parent class. It promotes code reusage and establishes a natural hierarchy between classes. When we talk about inheritance, it is not easy to put it all together in one presentation. So as we look into inheritance, it is a mechanism where a new class or a child class, if we look into our everyday life, we inherit certain properties or certain habits or certain behavioral changes from our ancestors or from our parents or from our grandparents or anything like this. This in Java, this helps us in many ways. We do not have to write the same code. We took the example of adding. I don't have to write the code to add two numbers different separately and add two strings separately and add some other data type separately. I can just create one class named add and then just make required modifications to you reuse that code and not waste time or memory space trying to make the computer understand the same thing. So this also establishes a natural hierarchy, because a superclass or a parent class would have more properties and would be larger and more significant compared to the child class, which is just using the properties of the parent class. So this sets up a natural hierarchy, or like different stages in our program, that helps us to uh, actually make decoding and like debugging and other things easier. Polymorphism allows objects to be treated as instance of their parent class rather than an actual class. This enables a single interface to represent different underlying forms or data types, enhance flexibility and integration. And polymorphism is basically helping us to be more flexible with our code, and how it can, all different parts and bits of code that we have written are used to, this is like integrating them all together or just putting it all together so we can understand it better and can, so that they can work together and make better changes or outputs. Encapsulation. It is the bundling of data and methods that operate on that data within a single unit and restricting the access to some of the object's components. It helps us in protecting the data from unauthorized access and modification, ensuring the data integrity. Now, as we spoke earlier, encapsulation is basically bundling up of all these different methods and variables that are operating on certain data. It is more like a house where we have a kitchen, we have a bathroom, we have a bedroom. We don't sleep in the kitchen and we don't cook in the bedroom. Similarly, we do not, when we don't want certain activities to happen on that data, we can restrict it by using the concept of encapsulation. So we put together that required amount of data, that required amount of methods that we are using to perform the operation on that particular data, and we can provide access to only the ones that we want to. Like once in a while you may want to sneak food on your bed and have a packet of chips on your bed. So similarly, it is like just a new way of just ensuring that things don't go wrong and having the integrity of our data. Abstraction is a concept of hiding the complex implementation details or showing only the necessary features of an object. It reduces complexity by allowing the user to interact with an object at a higher level. As we spoke earlier, abstraction is basically data hiding, and we don't mean to hide the necessary data. We only need to hide the unnecessary information of that object. Like we may be talking about Tommy, and we don't have to tell everybody that Tommy is shedding fur everywhere and he has problems. All the when somebody asks us about Tommy, we just say he's a retriever and he is in a certain color. He's these many years old. We don't explain the diet of Tommy, how much water he consumes, how much sleep he gets. Everything is not necessary at some point. So hiding these data in our example could be an example for abstraction as well. Example of implementation of OOPS in Java. Practical example of OOP concepts implemented in Java. We have an example of creating a class and object here. Here the class that we have created is a student. Integer ID, that ID is a variable that we are using. String name is also an variable. Int and string are data types. So public static void main is the main function for our program. So we are trying to create an object. Student S1 is equal to new student. New is a keyword used to create new objects. And system.print out.println is a standard output statement. And then the output for this program would be a class, would be an object that would store the ID and the name that we enter in the output stages. And at the end, I would like to say that these fundamental elements of Java allow the creation of robust and scalable software designs. Understanding how effectively to use classes and objects can help us write more organized modular codes, which is easier to manage and extend. Not only that, the concept of OOPS also helps us to make our debugging easier. It makes the program more understandable and less clumsy, or makes the code tidier. And also the object oriented programming, as we read earlier, promotes reusability of code. It also reduces the number of lines of code and also does not make the code unnecessarily lengthy. And many such features of object oriented programming is why it is used so much all over the software industry to develop all these different programs. Last but not least, I would like to thank you all for watching this video. Thank you.